Hi, I'm Lev. I'm the author of PgDog, and in this video, I'm going to show you how PgDog works. Let's jump right in. I have PgDog running on my local on port 6432, and it's connected to three databases, our three shards. Let's go ahead and connect to PgDog with pSQL. pSQL is a client for Postgres that you can use in your terminal. Here we go. Let's take a look in our schema, and we don't have any tables. Great. For this demo, I'm going to show you how to create a sharded key value store in Postgres. It's a really simple use case, and we're just going to create one table. I'm going to go ahead and do it now. KV, I'm going to call this table KV for key value. I'm going to give it a unique ID, a big int, make sure it's not null. And I'm going to give it a special default, and I'm going to explain to you what this does in a second. And let's put some data in there as well. Let's call it column data. Data type JSONB. With JSONB, you can store pretty much anything. Perfect. Before we keep going, I'm going to go ahead and enable debug logging in PgDog. And what this will do is it'll allow us to see what's happening underneath when we execute queries through PgDog. If you're just learning how PgDog works, this is a great way to understand its internal mechanisms. Perfect. So debug logging is on, and we are good to go. I'm going to go ahead and reconnect because I just restarted PgDog. Perfect. Let's take a look at our new schema. I'm going to run d+. And this is our first interaction with a sharded database. And what we have here is actually, we have three tables, one per shard. And let's take a look at the debug logs and see what happened. D+ is actually a query. pSQL generates that query and sends it to Postgres. But because this query is not sharded, PgDog will send it to all the shards. And you can see this routing decision in the logs right here. And this is the query. And when the results come in, what PgDog does is it will forward all the rows directly to the client. So instead of seeing only one table from one database, we are seeing three tables from all the three shards simultaneously. Let's insert some data into our new key value store. And to do this, I'm going to use the insert query. And I'm not going to specify an ID. I'm going to let Postgres generate one automatically. And let's insert some, let's call it some fruit, orange. And at the end, I'm going to append return star to return the row back. And this is important because the ID will be generated by our sharded database cluster, and I need to know what that ID is so I can retrieve that row later. So what happened here is I created a special PGSQL function that can generate unique IDs for a sharded Postgres database. And how this works is the sharding function inside PgDog is the same hashing function used by Postgres partitions. So when you insert data into Postgres going through PgDog, we're able to figure out not only which shard it has to go to, both inside the pooler, but also inside the database. Let's take a look in our debug logs, and this is where the insert query was parsed. And what happened here is that PgDog saw that this is a sharded table, and because it's an insert query, it decided that it should go to only one of the shards. And this allows us to evenly distribute data between all the databases. The algorithm used by PgDog is called round robin. So it's going to start at shard 0, and then for next query, for next insert, it's going to go to shard 1, and the next one to shard 2, and then back to shard 0. We are using the Postgres native parser. It's the actual C code from directly inside Postgres. So we're able to understand every single query that Postgres can as well. Let's keep going, and maybe let's fetch that row back using a select. Select star from KV where ID equals 38. So this is a direct to shard query because the sharding key is inside the query. PgDog is able to hash or shard.number and route the query to the correct shard. And if you look in the debug logs, just here below, this is where the query is. And again, PgDog saw that the ID is equal to, what was it, 38? That's right. And it sent that query to shard 0. Let's insert a bunch more data so I can show you a few more interesting queries. Let's add some apples and some tomatoes, which is technically a fruit because it has seeds. And maybe some dragon fruit, which I've never tried, but I really like the name. And let's add a couple more oranges. Orange and one more orange. Actually, there we go. Perfect. So I just inserted a bunch of data in my table, but I have no idea where that data is or how many rows I have. So what I'm going to do is just do a select star from KV and see what's inside. Perfect. So this query is actually a cross-shard query because it doesn't have a sharding key. So if we look inside the debug logs, I'm just going to scroll up a little bit here and find it. Here we go. So this is select star from KV, and this is a cross-shard or all-shard query. And what happens in this case is PgDog connects to all the shards, sends the query everywhere, and as it receives the results, it sends them directly back to the client. And this is what we see. This is all happening on the network layer inside PgDog. So neither does the client or Postgres know that they're part of a sharded deployment. Let's run a query that's a little bit more interesting. Let's select all the rows, and then this time let's order by ID. Perfect. So in this case, the situation is a little bit different. Because we require ordering across multiple databases, PgDog can't just send the rows as they come in. What it's going to do is it's going to buffer the rows in memory. And because we use the Postgres parser, we're able to detect that there's an order by column in the query. And we're going to hold the rows in memory. And once we receive all the rows, we're going to perform sorting inside PgDog and send the queries back to the client in the exact order that it requested. Let's run a query that's a little bit more interesting. Let's perform a cross-shard aggregate. And to do that, I'm going to select count star, and then I'm going to get the name of the fruit from the JSONB structure, from the KV table, and I'm going to group by 2, which is the name of the fruit, and order by 1, which is the count in descending order. Perfect. So this is actually a cross-sharded aggregate. And how does this work is PgDog, again, using the Postgres parser, is able to detect that there's an aggregate request inside the query, and it knows which column is the aggregate key. And of course, ordering is still working as well. And it will send this query to all the shards, receive all the results, and buffer them in memory again. And because this is an aggregate, the working set is actually be quite small. And it's going to perform a secondary aggregate on the results. Support for aggregates is still a work in progress, but the basic ones like count, sum, min, and max are already working. Let's make things a little bit more interesting. Postgres is a relational database, so let's introduce another table, and let's use some joins to connect the two tables together. Before I do that, because I want to use foreign keys in my second table, I'm going to create a unique index on the primary key of my KV table. So on table KV using btree ID. Oops. Here we go. Perfect. And this works because our ID generating function uses a sequence behind the scenes, and that ensures that all IDs across all 3 shards are always going to be unique. Now that I have a unique index on the primary key, I can create a second table with a foreign key reference. Create table, let's call it KV meta. Let's give it a KV ID, that's our foreign key. It's a big int, and it's not going to be null. And it will reference KV ID. Perfect. Let's add a couple more columns, something like created by varchar, and then was that person an admin or not? True or false. Perfect. So just like last time, we have 3 shards, so 1 table per shard, and that's what we're seeing. 1, 2, 3, 4, 5, 6 tables in this output. This is a good time to show you how PgDog is actually configured, because we're going to have to make a small change. So let me show you what we have. This is pgdog.toml, which is the main configuration file for PgDog. And inside you're going to have all your databases. This is shard 0, 1, and 2. And this is our sharded table KV with the primary key ID, data type begins, and it belongs to the database Postgres. So to add another sharded table in our config, we're going to have to specify it here. And I can see what you're probably thinking. Like, adding this config for every single table you're going to add to your database is going to be pretty tedious. So what you can do instead is, let's specify just the name of the column, which is in our case is KVID, the data type, which is going to be begin, and the name of the database, which is Postgres. And this will work because foreign key convention, it is a convention, you don't have to follow it, but if you do, the name of the foreign key column will usually be the same. So every single query that will have KVID will be automatically sharded. Great. Let's reload the config so PgDog picks up the new changes. I'm going to go in here and do pgl PgDog. So I sent a reload hang up signal to PgDog, which tells it to reload the config. And this is what you should do in production, because if you restart PgDog every single time you make a config change, you're going to cause a bunch of errors to the clients. Perfect. All right, let's do a couple of joins. To do that, first I'm going to insert some rows into the new KV meta table. I need to specify the KVID now because it doesn't have a sequence, and I need to attach this row to a specific row in another table. So I'm going to do that. Created by an admin values. Let's go with 10. Created by me, and I'm technically an admin, so there we go. Returning star. Great. So this is a directive shard query because the sharding key kv_id is in the query, and we can see that in the debug logs here. Shard 1. And this is where the original row with ID 10 is located. So now if I can do a select star from KV, inner join KV meta on KV ID equals KV meta KV ID. And I'm going to say where KV ID equals 10. So this is an inner join, so if there was a mismatch between the rows, this would return nothing. But because this is a directive shard query that specifies the sharding key, this query was sent to one specific shard. In our case, it's shard 1, and the join worked like you would expect. PgDog has a bunch of other really cool features, but I'm going to save that for another video. Thanks so much for watching, and if you have any feedback or ideas, don't hesitate to reach out. See ya!